Okay, hello, welcome back. This is part two. I had to end part one abruptly because my little pencil died. So, we're continuing quadratic inequalities. In the last video, we just talked about a few examples where you find the roots and then you sort of draw a number line with the parabola and you find it like that. So, if you haven't watched part one, you should probably do that to follow along with this part because I already explained all that. Well, in this example and in this video, we're just going to look at one example, but we're going to kind of take a detailed look at it, okay? And that is looking at inequalities between functions. So it's not like specifically about quadratics, but a deeper look at function inequalities with, and let me just show you. So we got two functions, f of x, which is a quadratic, and g of x, which is a linear, okay? It says, give the solution set for the values of x, satisfying f of x is less than g of x. So what we're interested in is say, okay, here's f of x, and I'm interested in finding the set of x values such that f of x is less than g of x, okay? So to set this up, you just say, well, f of x is defined to be x squared plus 4x plus 7. This was just given to us. And g of x, I want to say less than, is said to be negative 2x minus 1. And now see, in the last video, we said, well, if you want to solve this inequality expression, right, then all you need to do is move everything to one side, set it in relation to 0, right? And then find the roots and do what we did. So you'll notice that this is very similar to what we've been doing. The only difference is, well, we're going to add 2x to both sides, and we're going to add 1 to both sides, and I get x squared plus 6x plus 8 is less than 0. So I've got this. I need to find the roots. We'll check and see if it's factorable, and I'll see that, oh, well, this is 8 and this is 6. So 4 and 2 work. And I'm just going to shortcut this factoring and say x plus 4 and x plus 2 are less than 0. That means the roots are negative 4 and negative 2. So I'll make my little number line, right? Here's my number line like this. And I say, okay, the roots are negative 4 is right here, negative 2 is here. And as a reminder, in the last video, we talked two ways you can do this. You can plug in a number and see if that makes the inequality true, or you can just think about what the parabola looks like, okay? So I'm just going to look at this inequality right here. If I look at the positive coefficient, I'm sorry, I'm kind of yawning a little bit. Apologies. The leading coefficient is positive. Therefore, this is going to be a U-shape like so. So I'm going to put these 2 points here. I'm going to go whoop. Well, that was terrible. Let's try that again. Whoop. Well, it was slightly better, but still not perfect. But there's my parabola. It's facing upwards because the leading coefficient is positive, so it's a U-shaped parabola. And this, so that this means is it's negative down here and positive on the outskirts out here. And we want the inequality less than 0. That means we want negative, and so negative's in between those two bounds right there. So the solution to this is it's less than negative 2, but more than negative 4. And that's it. And you'll notice, like, look, was this that much different from what we were doing in the first video? No. The only difference was algebraically, you had to set up the inequality, right? It wasn't totally given to you, so you had to set that up, and then you had to move things so that you had 0 on one side, okay? From there, it was just like all the same steps as the video showed previously. Now, I say, why did he say, I was yawning again. I'm really sorry. I don't know why I'm so tired. It's not even 9:30. Anyway, I want to take a deeper look at this, okay? So algebraically, you've got it, and if your goal is just to, crunch this out or whatever, you're done. But I don't encourage that. Why? Let's think about this at a deeper level, right? Why is it that when I set it less than or equal to 0, that this is going to actually help me figure out the solutions to this question? And in fact, what is this, f of x less than g of x? What is that even asking, actually, right? What does it actually mean? And so we're going to go down here, and we're going to look at method 2. So it says graph f and g on the grid below, and then we're going to label the points of intersection and shade the region such that f is less than g of x. So let's just first graph these things, okay? I'm going to start by graphing g of x. So I'm going to get a little blue here. So here's blue. G of x is easy because it's linear, right? And so it's negative 2x minus 1. That means it has a y-intercept at negative 1 and a slope of negative 2. And so I'm just sort of filling in these points. I'm just making a nice, really accurate line right here, yeah? That is the set of points for G. I'm just draw a little straight line here. Love that the iPad can do that. That's really nice. And I've got G, and that took me no time, right? In red, I'm going to do the parabola. Now, this one's a little bit tricky because if you want to graph this, first of all, you do see a y-intercept at 7, so I could say 0, 7, and that's true. But if I really want to know a really good picture of this parabola, I probably want to know where the vertex is. So I'm just going to take a minute here to find vertex form, okay? So we take the big guy, divide him by 2, then square it, and you get 4. Because I'm doing 4, right, b over 2 squared. So I'm doing 4 over 2 squared is 4 plus 7 minus 4. And then this should factor as x plus 2 squared plus 3, which means the vertex is left 2 up 3. So it's actually going to intersect right there is where they're going to touch, okay? By the way, if you're saying, what the heck did he just do right there? That means you need to go watch lesson 4.2, yeah? Because I just took this from standard form to vertex form by completing the square. So if you don't know what I did there, go check out 4.2, okay? I'm going to make a little table so that I can generate a lot of good points here. I know that I had 0, 7, and I just found that it was left 2 up 3 via my function transformations. Let's find the point negative 1. So if I plug in negative 1 right here, negative 1 plus 2 squared plus 3. Well, negative 1 plus 2 is 1, so 1 squared plus 3 is 4. So when I plug in negative 1, I get 4. So negative 1 is 4 right there. Beautiful. And since I know that this point right here is the vertex, then I can kind of mirror, I could do an axis of symmetry business, right? And I could, why did it mean to get rid of that? Whoa, what? Okay. Don't just erase that. All right, so I'll mirror these points over, right? And I'll say, okay, well, then here's a point here. And then, look at that. Ooh, right? And I've got this. And I think that's sufficient to have those points. I guess I don't even really need that table that much, but I will connect all these points like this. Can I make a nice parabola? You know what? I'm going to zoom in here. I'm going to be really nice with this, okay? I'm trying. It's a little hard on an iPad. At least I find it's hard. Do you ever see people draw on iPads for real? They do animation sketches and stuff? I don't know how people do that. For one, I can't draw on paper, but I would be hopeless drawing this on iPad. Okay. But that's actually not pretty. That's pretty good. And so I've got the curve like this, right? Now, if you think about this, if you're thinking about when f of x is less than g of x, right? Well, f of x is the red curve, and g of x is the blue curve. And so what that means is when is the red less than the blue? Not the buell, the blue, right? And you'll say, well, what that means is the red line is below the blue line. Is what that means. So I can kind of see, well, if I want to highlight this, right here they intersect, and along this piece is where the red is below the blue. And they're intersecting at -4 and -2, and so it's all in this region between -4 and 2. Hey, wait a minute, isn't that the thing we just were answering, right, in the previous right? Oh, yeah, I'm getting this, right? So the answer to the question, when over what interval is x is f less than g, well, it's this interval, which is from -4 to -2. And so graphically we can see that. But you'll notice that, when we're doing this little number line business up here, well, what the heck? This picture doesn't look like anything like this picture. So where is that even coming from? And I say, well, where it's coming from is you're taking f of x, right? So if you're saying f of x is less than g of x, right? But the algebraic technique I said was to move everything to one side, set it equal to 0, right? So if you subtract g of x, set it in relation to 0, it would look like this. And so, if I had two functions, f and g, and I just took their difference, I could just call that a new function, h of x. Now, we actually already found this thing. It's the thing less than 0. And that was right there. Okay, I'm going to kind of maybe erase those two things and highlight that for you. That function right there is the result of subtracting the other thing, right? Because it's essentially, I'll just show you. If you had f less than g, and then you did, okay, so f of x is this function, but then you're subtracting what g of x is, which is -2x minus 1, right? Then this is like plus 2x plus 1, which is the inverse operations we did right there. Yeah, so that's why this is the difference between those two functions. And so I'm just going to copy that. X squared plus 6x plus 8. X squared plus 6x plus 8, right? Now graph that, right? You say, well, how do I graph that? Well, make a nice, accurate graph. First of all, you could factor, which is something we did. We said it was x plus 4 and x plus 2, telling you that the roots were here and here. And if those are the roots, then via axis of symmetry, you'd know that the vertex is at -3. So we could plug in -3 for x, right? And that would be 9 minus 18 plus 8. That's like 9 minus 10 is -2. So my vertex would be right there. And if you don't believe me, by the way, you're saying, where did he even get that? I say, look, these are the roots, and the roots are symmetrical from something, so the vertex would have had to be halfway between. That's how I kind of found that. Alternatively, you could complete the square on this. Take the big guy, divide them by 2, which is 3, and then square it, which is 9. And then this would factor as x plus 3 squared, and then 8 minus 9 is -1. So notice this is left 3 down 1, left 3 down, what? Did I do my math wrong? Is it, I assume that that's true, that it's right here. Did I do my math wrong when I plugged in -3? 9 minus 18 plus 8. Oh yeah, duh. 9 minus 10 is -1. I said it was -2, my bad. Okay. So I have a few points, and I could find a little bit more. I could plug in -1, -1 squared plus 6 times -1 plus 8. That's 1 minus 6 plus 8. Is this -5 plus 8? It's 3. So that's 1, 2, 3. So I could put that there, and then I could mirror it and get this. Okay, so this is just an accurate curve of what I'm seeing right here. Okay? Now what you're doing, you see, is you're taking the two functions subtraction and looking at when that new function, which is the difference between the two, is less than 0. And where it's less than 0 is right down here, right? This is where it's negative. So it's in between -4 and 2. -2. So this is kind of the connection, right? Or this is like what I'm trying to show you is this image is the question you're answering. When is the function f less than g? Well, it's less, and visually you can see it's less right here, and that's this interval. But algebraically, what you're doing is when you move everything to one side, you're essentially creating a new parabola that you're just analyzing when it's less than 0. And this is all kind of fine because the solution to this parabola being below 0 is the same solution as when this parabola is below that line. It's just kind of interesting, This is the answer to this question right there, which is kind of cool. Okay. One last little tidbit, and that, look, again, this was just for the sake of it. It was just kind of neat. And this says, think about it. It says, let f be this and let g be that. It says, give the solution set for values for x satisfying that inequality. So same thing we were just doing. You'd say, okay, I want to find when f is more than g. And so you'd say, okay, f is this. This is a fun little think about it exercise. So I have that. And I could, of course, set it in relation to 0, so subtract g to the other side. And if you do that, you'd get this right here. Because you're minusing 3x, so you get negative 4x on the left side. You're subtracting 7, so you're getting plus 20 on the other side, okay? Now, sadly, this is, I don't think, factorable, because 20 and negative 4, you could do 10 and 2, doesn't work. 5 and 4, doesn't work. 20 and 1, doesn't work, right? So it's not factorable, which means you use quadratic formula. So the roots are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll do this algebra a little quickly. You're welcome to use a calculator, pause, or simplify if you'd like. My goal here is not to show you the quadratic formula. We've already covered this. I want you to look at what happens when we get this result. So I'm going to have, this is 4 plus or minus 16 minus 80 over 2. Now, 16 minus 80, why am I struggling with that? Is that 64? It better be. 4 plus or minus negative 64 over 2. And that's actually kind of nice, right? Because that's 4 plus or minus, the square root of 64 is 8. But the fact that it's negative 64, so this is 8i, right? And so this is over 2, getting me 2 plus or minus 4i. Now, wait a minute. That's kind of weird, right? You say, what does that tell you, right? Well, the roots of this parabola, this one right here, are imaginary. And if you think about that on, if you're graphing this parabola, if this is my number line, well, I don't have any x-intercepts on the real axis, right? So because my roots are not real, they're complex. They're imaginary here, right? So I say, well, what the heck? Well, what that means is it doesn't touch the x-axis. So it either is above it or it's below it. And I'm not actually sure which. But what's kind of nice is knowing that wherever it is, if it's above or below, it's for all real numbers, right? Because it's either the whole parabola is up here or the whole parabola is down here. So if you just figure out whether the parabola is positive or negative for any real value, then you'll know where it is. So just what's the easiest one to do is plug in 0. 0 squared minus 4 times 0, that's all 0, plus 20. Plus 20 is positive, right? So what that means is the parabola is above for all real numbers. It's always above this sort of x-axis here. And we were interested in when it is positive, because I want it to be greater than 0, so I'm looking for when it's positive. Well, it's always positive. The whole thing's above this. So what that means is my solution set is all real numbers. All real numbers satisfy this inequality. And what does this mean in terms of the graphs of f and g, right? So I'm just going to jump to Desmos and show you this. You have x squared minus x plus 27. Let's go ahead and do that. X squared minus x minus 27. Plus 27. Also, I'll fix that. And 3x plus 7. So this is plus. And then I got 3x plus 7. Boop. Like so. And you can see that the parabola and line don't touch. And if the question is asking when is f more than g, where f is the red and g is the blue, well, the parabola is always above the line, right? And so, the roots are complex because these two functions don't meet at a real value. They just don't. And graphing them, you can see that the parabola is always above the blue line. So we would say that the solution set where f is more than g, which means f is above g, is all real numbers. And that would be the sort of justification to that. Yeah? And we could know this because you said, well, Mrs. Make, what if I didn't have Desmos and I wanted to understand this? I said, well, you could quickly sketch these just slightly. You could say that the linear function has a y-intercept at 0, 7. So it looks like this. But the quadratic function has a y-intercept at 27. So that's way up here. So that means it's got to be doing something like this, right? Just a brief sketch, because they're never going to touch. So the y-intercept was up there, and it's a positive lead coefficient. It means it's probably facing upwards like this. Well, it has to be. So they don't meet, and it's above it for all real numbers. If we found that it was below it, then it would have been no solution. It would never be true. Yeah? Okay. I think that's it. This covers this. It was just one example and then another little extension there. Hope you found this insightful, fulfilling, just informative, and maybe giving you a little bit more of the why behind why these algebraic processes work and interpreting what the goal of what we're doing really is. So, thanks for watching, and I'll see you later.